I don't know who is eligible, but there are some scholarships for people. If you're interested, come up and take a look at this. If only one person is interested, you can take it. It's a flyer. Okay? That's number one. I'm sure you all want to talk about the, not all, 4 or 5 people got 100, and then a few others got 98. Some of the scores were very, very good. The average was 83. That's the mean. And the median was 87. I think that was also, if you know the mode. Mode is the most frequent. And I think that was also 87. But those scores are going to improve a little. Before we talk about the quiz, I'm going to do it's called a mea culpa. It's Hebrew. But it's English idiom. Means it's kind of like saying I made a mistake. And the mistake I made, well, I've been teaching math quite a while, but when I took math, we barely had calculators at all, and I didn't think of them as something you had to learn to do. But they were simpler calculators, and now they're very complicated. And I assumed that the fact that everyone had taken Calc 1A, I thought you'd have had experience with these. And not everybody, some of you really know how to use them. I'm sure you all kind of know how to use them, but there's some details that apparently were missed out. In particular, number 6. When I said using your calculator, what I meant was to use the calculator function. Now, if you use the calculator but didn't use the integration function. If you use the calculator but you didn't use the integration function and you got the right answer, I would have given you full credit. But as it turns out, I specifically gave you an integral that you can't do. I think I mentioned that like this integral, which is very important in statistics, we can't solve directly. And all I did is I took out the minus sign, so things really don't change. You still can't solve it. So you really had to use that function. Now, I showed you a couple times, but I really didn't spend much time. And I want to go through this a little bit. And when I'm done, those of you who lost credit on 6, I'm going to give you an opportunity to make up some points, right? On my website, I have a worksheet under handouts. It says make up calculator integration. And I want those of you who lost some points to consider doing these. They're a little complicated. They'll take you a little bit of time. But if you do them and hand it in, I will give you back points for that question. Because I feel like I overlooked the fact that not everybody understood what I meant. So, for some of you, I know that this is going to be, you're going to know all this already, and I apologize. We're just going to spend a little time. I have two now someone I loaned a calculator to, I like to trade. Who's borrowing a calculator? Let me trade with you. Who borrowed my calculator? You borrowed my calculator? Yeah, let's trade. Yeah. Trade. You give me that, I give you that. I want an 83 and an 84 because they work a little tiny bit different. Really not any important way, but a little bit different. Actually, I have two 84s and they both work different. So every one of these could be a little different. First thing I want to do is I want to say that there's a lot of things you can do with this calculator that I'm not going to talk about. I'd also like any of you who have a calculator here to take it out, especially if you lost credit on number 6, and follow along with me if you can. Okay? So, the first thing I want you to note is there are many functions on this calculator. Many of them are available on these buttons, but some of them may not be. And if you press the second key, no, you have to turn it on first, and you have to quit. You have to really quit. Second, catalog, right? You'll see there's a big list. Now, I don't use many of these, but if you can't find something, this is the place to look because it has all the functions. And in particular, a really useful function is the first one, ABS absolute value. You should know that these are all here. Okay? There also are kind of submenus, like, for example, if you hit stats, you'll see there's a bunch of statistical kind of functions. We have, on this calculator, matrix functions, math functions, okay, just general math functions. The calculators even have a programming capability. You could build a program yourself and use it. So there's a lot of capability here. I'm not going to do much more with it other than what I want you to know. But you should know there's a lot of capability here that can be very useful. Okay, let's get on to problem 6. Right? So for problem 6, you have to go to the y equals. If there's something already in the y1, you want to hit clear and clear it out. And just as a warning, if you use the cursor and you move up here where it says plot 1, 2, and 3, if one of these is selected by hitting enter, you see, you want to turn that off. I will only tell you I don't know what turning it on does other than nothing works after that. So make sure those are all deselected or turned off. Okay, now, to do an integration, the first thing we want to do is enter our function, which in this case is e to the x squared. So we need the e to the x function. You could actually just put in e. You could put in the e value, which is second e over here, and you could say raised to something, but we have a built-in function which does the same thing, e to the, no, I guess on this calculator it comes out the same. All right, so on this one, e to the x, it comes out the same. All right, so now we want to put in a variable, a independent variable, and that is this function here that it says xt theta or something else, some other Greek letter. Depending upon which mode you're in, we're probably going to look at one of the other modes. If you're in polar coordinate mode, instead of it being an x, it'll be a theta. And there's another mode I don't think we're going to cover in class called parametric equations, and then it'll show up as the letter t, t being the parameter. But in this case, we want to put in x, and now it doesn't matter, we could say x times x, or we could say x squared. I'll just do x times x over here. And one nice thing about these calculators, you don't have to close the parentheses. If you're going to do more, like if you're going to multiply this by something else, you might have to close the parentheses, but you don't have to. Okay, so we've entered our function. We want to integrate this function either from, what was it, 0? Was it 0? Yeah, 0 to either 0.5, or if you read it as 5, to 5. So the next thing you might want to do is check your window and make sure that the x minimum and maximum are big enough, right? If they're too small, if they're smaller than this window, when you do the integration, it's going to fail. I don't know why that is, but it's just the way it works. So at the very least here, I'm going to, I just mentioned this, you probably find this out really quickly. There are two minus signs here, but the minus sign over on the right here means subtract. The minus over here means change this number to a negative, right? So here I'm just going to make this minus 1, and the maximum 6 sounds fine. Here I'm going to again say minus 1 and 6. All right, now I've got my window set up. I'm going to hit the graph key just to take a look and make sure my graph looks okay. And then the last step is to invoke the calculation menu. It's not the last step, which is the second key calc. Second key calc. It's the button that says trace. We're not going to trace. Now we have a list of 7 items. You can choose an item either by using the cursor and enter, or you can just press 7, because we want the function at the bottom. It says integral f of x dx. All right, so we'll do this on both of them. Now, at this point, there are various ways you can enter the limits. You can enter the limit graphically using your cursor keys. Usually we don't do that. Typically you just enter a number. But you should be aware that when you enter a number, you can enter a number or you can use any of the functions on the calculator. So for example, here I'm going to enter, say, 0 as the lower limit. But if I wanted to enter pi or pi squared or something like that, I could say pi squared, and that would be that limit. It's not really what I want to do, so I'm going to go back and delete those. Okay, so the original problem actually said 0.5, and so I enter, and then you see graphically the area, and then on the bottom you see the value 0.5449871. I think pretty much everyone who saw it was 0.5 and did this calculation, got it right. If you need that number in a further calculation, which is possible, you can pull it into the main screen by saying second answer. And answer is just that value. On the other hand, if you had said 0 and 5 is the upper limit, then you probably had to wait a little longer because this is a little harder to calculate. It takes a little longer. And now you want to look real carefully here. See that number? It says 7.35415 E9. And to anyone who did a 5, I want you to look really carefully at that E. Right? This is exponential notation. It means E9 just means times 10 to the 9th. So if you're one of the many who left that off and had 2 points taken away, you probably want to do the worksheet. It's probably worth 2 points to do this. Just a little practice. If you completely lost credit, I know you want to do the worksheet, right? I'm not going to put a time limit on it, but it would be best if you do this within the next 2 weeks. That'll give you plenty of time. Okay, so is everyone clear on that? If you lost points on number 6, you know, do some practice on the calculator. By the way, if you get it wrong, that's okay. I'll mark it wrong and hand it back and have you do it again. If you're really having trouble with it, I mean, you know, I think it should be pretty clear now, but you can come see me and we'll go over it. But I think it's important today for you to really know how to do this with the calculator. So if you're planning to do that and your grade was down a little, just mentally add those points back into the sheet and we'll be good. Okay? All right. Now, there are a few problems I want to talk about, and then you may have some questions. So, let's see, I mentioned, 9. I mentioned this only because I was a little disappointed. Many of you got it exactly right, and a large number of you made the same mistake. Even though we had done a number of these problems, you ignored the absolute value sign. Now, when you get a problem like this, it might help. It might help to graph it, just to take a look. You know, think about the calculator. It's not always going to give you the answer, because I may ask for an exact answer. But you can certainly use it as a tool to get a feel for what's going on, right? So, like in that last graph I showed you over here, you can see this is all filled up here. It's a big number. It's a lot bigger than 7, or 700, or 70,000, right? It might have been a hint that other problem was wrong. But let's just take a look. Again, I don't know if ABS is on all the calculators but you can go to catalog and pull it in. Absolute value of, by the way, absolute value of 2 minus x. What's the difference between absolute value of 2 minus x and absolute value of x minus 2? What's the difference? The trick question. There's no difference, right? So I can just put in x minus 2. And let's take a look at the graph of, oh, well, I'm going to fix the window because it's not helping any. There we go. All right? So that's what the graph of this looks like. The area under it is all positive. But it changes at what? 2. So from less than 2, you get one line and one function, one linear function. And greater than 2, it's a different function. So just from that alone, I can say, hey, this is integral from 1 to 2. And I could actually move the absolute value outside of this at this point. Plus the integral from 2 to square root of 5, x minus 2, absolute value. Now one of these is going to be positive and one's going to be negative. And the negative one I'm going to make positive. All right, that's what that graph kind of looks like this tells me. All right? Now, I'm pretty sure everyone here can calculate this pretty cleanly, so I'm not going to go through it. So are there any questions about this problem? Okay. The last one I want to mention, I didn't understand. I had to go back and actually look at the homework and see that I had given you problems like this on the homework, because I thought maybe there was a language issue here, but I don't quite see how that can be. I think I'm gonna turn this off now. I don't really want to. Problem number 9 says function 4x minus. It's like from a horror movie, isn't it? Yeah, how? Take it off. Here. Okay. The problem says on the interval 0 to 4, and it doesn't say anything about finding the average value. You do have to find the average value, but it doesn't. I guess I'm going to move this over too. It doesn't say anything about finding the average value. It says find C, where f of c equals the average value. And the thing that throws me off is a good number of you found the average value and stopped. You just stopped. And I didn't quite understand why that is. Maybe during the break people will tell me maybe I could have worded it better. But in any event, you find the average value. I think most people were able to do this from 0 to 4 divided by 4 minus 0. And most of you got the correct number, 8/3. You could have even used your calculator, used the calculator function, and you'd see something like this. And with a little, scratch in your head, you'd go, oh yeah, that's 6 repeating, and that's 2/3, and so it's 8/3. But then the problem was, how do you find f of c equal to 4c minus c squared equal to 8/3? And this is an algebra, high school algebra problem. Maybe it's the context. You didn't understand in this context that's what we need to do, but let me go ahead and do it. To make it simple, I'm going to multiply through by 3. So I get 12c minus 3c squared equals 8. And then I'm going to write it in standard form. 3c squared minus 12c plus 8 equals 0. And from here, I can use the quadratic formula. Say 12 plus or minus the square root of 144 minus 4 times 8, 32, 96, all over 6. Now, if you just, skip this step and use the quadratic on that, that was fine too. It also would have helped, I think, if you took a look at this function, right? Sometimes a picture is worth 1,000 words. Right, so what does this look like? Well, you can graph it on your calculator, and it's going to look like this. It's an upside-down parabola, and this is the area. And you can see that the average value is going to be something between 0 and whatever the maximum is here. I forget what the maximum is. Let's say, what is the maximum? 4 minus 2x. It's at 2, so 8 minus 4 is 4. Okay. So if this is 4, the average has to be between 0 and 4. Okay, so it's 8/3. And since this is symmetric, you can see right away there are going to be 2 spots. I don't know what they are, but 2 points on either side where it achieves the average. So, I thought this would be the hardest thing on the quiz, but I didn't think people would just stop. That kind of threw me. So, okay, those are the problems I wanted to talk about. You're free to ask me about anything else. I'm going to say something before somebody asks. Someone asked, why, if you stopped halfway, didn't you get partial credit? All right? Partial credit to me is, you got something wrong, and I look at it and I say, oh, you made maybe a simple mistake, you put a plus where a minus is, or you showed me you kind of understood most of the problem, but not 100% of it. And to me, there's another problem on here about averages. This problem is really about the mean value theorem for integrals, and if you just stop there, to me, you didn't do the problem. So, you can come and argue with me later if you want, but I think that's fair. Okay, Sam?
So I did this one, and I didn't get it to the 12c minus 3c squared step. I just left it as negative c squared plus 4c plus 8/3. And I got like a value two values that match your answer, but they don't look the same.
And did I mark it wrong?
Yeah. Could I?
Well, show it to me and I'll fix it.
Okay.
Could be a mistake on my part. Probably is. Yeah, if you just think I did something wrong, just don't bother me now. Come up at the break and we'll fix it.
Well, I sort of asked because I didn't know.
I'm not blaming you. I'm just telling everybody else.
I know. I'm asking though just because I didn't know if that was the way we were supposed to do it or not.
Well,
You
I
know,
don't,
that, like, to just to simplify it.
I mean, this doesn't look like, this looks like it's gonna come out, I could do it. It's gonna come out with some kind of radical. I mean, if instead you said, you know, let's divide everything by 3 again, or 8/3 if you said 4 plus or minus the square root of 16 minus 32 over 3 all over 2, and I wrote that wrong, then I made a mistake. So, okay. "42 students, 10 problems, 420 problems, and 2 homeworks in 2 days." So I apologize for making a mistake, saying a couple, but
Don't worry about it.
but no, I bring it up and I'll fix it when we have the break. Any other problems, questions people have a question about? Okay. If you did poorly, well, let's just say if after getting these points back that I know you're going to get, if you did less than say a 70, then you're probably in a little trouble. And I'd like to remind you that there's a facility here called the STEM Center. It's down near the math office, where you can come in and they'll help you. They'll do tutoring. Certainly, if you had problems doing this, doing the quadratic, yes, you need their help. I'll help you if you come in for office hours, but I'm just saying. If you did somewhere between that and, say, a 90, and you're not happy with your grade, we could talk about things you might do. A lot of the errors I saw, I would say about 10-15% of the errors were very, very simple things. Things like, just like I said, like changing a plus to a minus in the wrong place. And when I find those, I don't usually take off more for them. I understand that the test is a stressful situation. But it would help to learn, some strategies during a test so that you can focus and not get too nervous. A little nervous is probably good, but not too nervous. So, all right. Any other questions on this? Right. Okay. Next item. Anyone? It's been requested. This is the worksheet from Tuesday. It's been requested I put an answer sheet up, and I will. But I'd like to know, did anyone do the last problem? I assigned number 3, 1 minus e to the x over 1 plus e to the x. Anyone want to suggest a substitution for that might work? I wanted to cover this before we go on to today's material. Oh, I'm sorry. There's one more a little bit. Oh no, we figured out who all those are. Oh, anyone? No ideas? U equals. What could I do? What could I substitute that might help simplify this? You can guess. It's okay if you guess wrong.
Right, that u equal to 1 plus e.
U equals what?
Equal y plus u x.
Okay. I think that's a really good idea. But can you tell the class why you thought of that? I mean, did you do it already?
Yeah.
Oh, all right, so you already know it worked.
Yeah.
But imagine you hadn't done it yet. Can you think of why this might be a good thing to substitute?
Because others cannot work.
Okay, I can't argue with that. I was going to say, well, it's the denominator, and the denominator is kind of messy. We can make the denominator less messy. That might. Do you want to say something?
Well, after you split it up, you can first split it up to top.
You can split it up. You mean like
Into
as
two
in,
integrals.
and like that?
Yeah.
Yeah, we're definitely going to do that. Although, I guess you could do this first, actually, right?
Yeah.
Right? But then you still have to do a substitution here, I think.
Yeah.
All right. Well, let's go with this. Let's see what happens. Du is what? E to the x dx. So this is clearly going to become u. I think you're right. I think you do have to split it up first, don't you?
Yeah.
Yeah. I mean, we're going to get e to the x dx out of this guy, but not out of this one. All right. So we have 1 over 1 plus e to the x. E to the x over 1 plus e to the x. Okay, so we're going to substitute here, right? This is going to be du over u. And that's easy, right? That's just the log of the absolute value of u, which is just going to be the log of the absolute value of 1 plus e to the x. Okay, that's good. How about this? Doesn't look quite as easy, does it? I haven't done this one yet. Yes?
Or another way is you could just make the numerator 1 minus e to the x, and then you can change it to 1 plus e to the x minus 2 e to the x, and then that way you can...
I didn't catch all of that, but I already like it. I mean, I feel like this is, I could be wrong, I feel like this is a dark alley. So we're gonna try this other idea. You're saying make it 1 minus e to the x?
No, you keep the same u, but then you would just, the original expression, you would just change it to 1 plus e to the x minus 2 e to the x. So it's still the same value, it's just...
I'm talking about this.
The numerator, yeah.
Make it 1 plus e to the x.
Minus 2 e to the x. And then all over 1 plus e to the x.
That sounds really good.
And that just applies to 1, and then you can just take that out and make it x.
Superb. I'm going to take a look at that and see why that's so bright. Right. Well, this is just going to be 1, right? And this has that form that we know we can get to using that substitution, right? So this is equal to the integral of 1, which is just x minus 2 times. Now let's do that substitution. U and du. And so it's going to be x minus 2 log of u, or x minus 2 log of 1 plus e to the x, okay. And I'm missing something. Let's see. All right. Some of these problems we're going to do are not going to be that easy. You're going to have to think about them a little. There won't always be a formula. Okay, any other questions? Yes?
Sorry, can you explain one more time what you did in the step to make it 2 e to the x?
I'll tell you what I can't explain. I can't explain how he jumped to the idea of doing this, right? But clearly, 1 plus e to the x minus 2 e to the x is 1 minus e to the x. Right? It's all over 1 plus e to the x. Right? 1 plus e to the x minus 2 e to the x is 1 minus e to the x. Now, how did she know to split it up this way? You can ask her during the break. It's just kind of a, you fool around with it and you do a few of these and you go, oh, yeah, that worked, something like that worked the last time. But there's not always a straight, in mathematics there's not always like a, just plug it into this formula or use this algorithm. You have to be a little creative. Okay. Anything else? Yes?
So 1 plus 3.
Because this is an indefinite integral.
But the first one also made to plus 3, right?
I'm sorry?
The first one, the x plus 3.
I'm not getting your question.
So there are x
Do you
minus
want to see here too? Is that what you're saying?
first the x.
Oh. Okay, good question, all right? Yeah. So this is, we'll say plus c, and this is plus d, some other constant, right? Okay, so we'll call this e, where e equals c plus d. You can combine all the constants of integration into one. It's just a constant, right? That's a good question. We didn't really talk about that. But if you break something up and you get multiple constants of integration, well, you can break it up or leave it the same. It doesn't matter. It's just when we're finding an indefinite integral, you only need one. When we do a real problem, this number may obtain a value. Okay. Other questions? Okay. We have I think it'll be a fairly easy topic today. It'd be very easy if I could find my notes. We're going to explore in a little more detail this idea of regions or areas between curves. Now, if I have some integral that is the difference between two functions, I think it should be fairly clear that this is my g of x. There's some kind of area underneath it. And this is my f of x. Well, I guess I should just call this A, call this B. The area beneath f of x is all the area down to the x-axis. Area beneath g of x, that's this integral that you get by integrating g of x. And so clearly, the area in between is just going to be this difference. So I can write this as the total area beneath f of x minus the total area between g of x. Now, we've already done a number of problems like that, so it should be fairly clear with you know how this works. Now, a very reasonable question might be, well, what happens if the x-axis is up here, and I have some function, again, an f of x above some g of x. And I look at this same integral. Well, one way to think about this is, if I add the same value to both of these functions, if I add some value C, I add some value C, let's say C is some distance like this. What's that going to do? It's going to move both of these up above the axis. Right? Or if you like, it's just going to move the axis down here. Now in doing so, the area between these two curves doesn't change, does it? But if you look at this, this is just, again, a to b f of x minus g of x plus c minus c. This just goes to 0. So what that tells us is that by subtracting this lower function from this upper function, we get the area regardless of where the function is on, on the graph. Which is nice. We can forget about it from now on, right? It's that comic line. Forget about it. Right? Okay. But that's not the only situation we could come into that might be a little tricky. We've looked at this before, but what if these functions kind of overlap. Sometimes f of x is bigger and sometimes g of x is bigger. And we want to integrate a to b. Well, and again, we're interested in the area between the curves. So here, we really need to know where the point of intersection is. Right? So if, say this is C, and this is D, we can say that the area we want to calculate is going to be from A to C, it's f of x minus g of x. Now from C to B, C to D, it's g of x minus f of x. And now finally from D to B, it's again f of x minus g of x. This is how we actually calculate it, but of course all this is equivalent to this integral from a to b of the absolute value of f of x minus g of x. Okay, I want to do an example. I'm just going to erase this. So, example. So the problem is, find the area enclosed, that means between, closed by y equals x squared and y equals 2x minus x squared. Now, this is the type of problem where it's always help, if you're just totally thrown by these equations, you might want to graph them on your calculator. You put both of those equations in and it will graph them. So what will that look like? Well, y equals x squared is going to look like this. And y equals 2x minus x squared is an upside down parabola. It's going to look like this. And what we want to do is find this area between them. So we know that if we know this point and this point, let's just call them A and B, that we can find this by f of x minus g of x, where f of x is y, 2x minus x squared, and g of x is x squared. But we still need to find these points. Now, it sure looks like 0 is one of them, but let's play dumb. Let's equate them. They're both y, so we can eliminate y. So we have x squared equals 2x minus x squared, or 2x squared minus 2x equals 0. And this we can solve by factoring, right? Get rid of the factor of 2, of course. This is just x times x minus 1. So we know the places these two functions will cross are 0 and 1. Okay? This is actually a pretty simple one. We only need one integral, 0 to 1 of 2x minus x squared minus x squared dx, or 2 times x minus x squared dx. And this is what, x squared over 2 minus x cubed over 3, 0 to 1. So this will be 2 times 1/2 minus 1/3. 6, 2 times a 6 is just a third. Okay. Some problems are pretty straightforward and easy like that. Sometimes you have to work a little harder. So let's take a similar problem. I didn't think I was going to need this. That's terrible. I think I'll just leave those down, shouldn't I? It's going to take a minute for the cameras to warm up. Okay, so this equation is not so straightforward. These equations are not so straightforward. Again, we could use the calculator and get a rough idea. E to the x is going to look something like this. And x plus 2 is a straight line that goes through 2. Presumably these meet up here somewhere and down here. Say e to the x equals x plus 2. Anyone learn how to solve this exactly in algebra? I'm getting, yes?
Don't you ln's both sides?
That's the first thing I would try. ln of e to the x is x equals ln of x plus ln of 2. See, it didn't really buy us anything. We still have, this is just a polynomial, and this is a transcendental function. Same thing you have here. We don't have a good way to do this algebraically, which is why, pull down the strings, of course. Oops. It's nice that we have calculators. We're going to have to do a little calculator work here. Now, there's two strategies to doing this on the calculator. One of them is you plug in both equations, and there is a intersection function. Fortunately, being a mere mortal who didn't grow up with calculators, when I tried it, I couldn't figure out how to do that. So maybe we'll try it in class just to see if it's going to work for me here. But an alternate strategy which will work, is to say, well, let's take, we want to find the difference, right? We want to find the integral f of x minus g of x. And we want to know where where that function, f of x minus g of x, is 0. Because that's where they're going to cross, right? So let me plug that in. E to the x minus x plus 2. And again, I'm going to go to my graph function. I can see already that I want to move my window over, right? See if that'll do it. Okay, there we go. So now I can see the 2 points where it intersects 0. And now I'm going to go again to my second calc function. And you see the second function there is 0. So I hit 0, and now it asks me for the left bound and the right bound. It's going to calculate it for me, but it needs a little help. So I could type in a number here, but this is a situation where using this little, I don't know if you can see it. Yeah, I'm going to move my window a little here. It'll make it clearer. Let's move y from minus 4 plus 4. See if that doesn't do it. Yeah, you couldn't see what I was doing, so second calc 0. Okay, now you can see that little bug there? I'm moving around with my cursor. So now I move it to the left of the 0. I hit enter. I move it to the right of the 0 and hit enter. And now it asks for a guess. I guess you could speed it up if you have a good guess. But why bother? It's just a little computer. I hit enter, take whatever guess it wants. Okay, so now, pardon me while I steal this. I know that this point is negative 1.841406. Okay. But I'm not done. I want to find the second one. So again, I'll do the same thing. 0. And now I'm going to move the bug over here. Enter. And a little above. Guess. Okay, and now it's 1.14611932. Okay. Now, at this point, let me write this integral. So the integral I want to solve, oh, by the way, which is the upper? The upper integral is 2 plus x, right? X plus 2. So what I want is x plus 2 minus e to the x from negative 1.841406 to 1.14611932. Now, these are approximate numbers. At this point, I could complete, I could do the integral the same way I've been doing. I could find the antiderivative and plug in these numbers and find the exact area for these inexact numbers, which would give me an inexact value. But, again, why should I do that? I've got a calculator. It's already just an estimate. So, I already have my function in there, except it's in the wrong way. So let me fix that. X plus 2 minus e to the x, and now you can see really where the area in here I'm going to be finding. say second calc 7. And now depending upon how accurate I want to be, I can decide how much of this I want to put in. I'm just going to cheat here. I'm going to say minus 1.84. And the top is 1.146. And now I have my area 1.9490901. Okay. So that's how you would do an approximate problem like this. Finding the area between two curves. My f of x is minus x squared plus 3x plus 6 minus g of x. Absolute value of 2x. And you can get this. So, the problem here is that this function, absolute value of x, looks different if looks like 2x if x is greater than or equal to 0, and it's minus 2x, x is less than 0. So this function, if I want to, well, first I need to find out, where these intersection points are here. And I have to be a little careful, because if I look at minus x, that's going to, I don't know if you can see, it's going to intersect down here too. So I have to be a little careful about what my points of intersection are. If I set negative 2x equal to minus x squared plus 3x plus 6, which becomes, let's see, negative x squared plus 5x plus 6, or 0, or x squared minus 5x minus 6 equals 0, I'm going to get 2 points out of this, right? I'm going to factor it because it looks like that's easier to do here. And what am I going to factor?
Plus 1.
Minus 2 and minus 3?
No.
No.
Minus 5 plus
Minus 5.
minus 6 plus 1.
Minus, thank you. All these good algebra students. Okay, so the 2 points are minus 1 and 6. And you can see, on this graph that minus 1 is the point I'm interested in. Positive 6 is way down here and isn't relevant. So I know I want to go from minus 1 to 0, right? And I want to subtract this guy, minus x squared plus 3x plus 6 minus 2x, right? Plus, now I want to go from minus 1 to, I don't know where that is yet. So I have to do this again, but now I'm using the function 2x. Okay, so x squared minus x minus 6 equals 0. Or now we have x minus 3 plus 2. So these points are 3 and negative 2, but clearly it's 3 that I want to do. And now again it's minus x squared plus 3x plus 6, but now it's minus 2x. Okay. I could do that calculation, but you could do that calculation. Actually, it doesn't look that hard. But I want to skip that because there's a different kind of problem I want to show you. I don't want to miss out on. So what I want to do is find the area between the curves y equals x minus 1 and y squared equals 2x plus 6. Now, this is already a little different because this is not a bang bang. This is not a function. Right? I think we have to take a look at this. This is a parabola, but it's sideways. And it kind of looks like this. And then we have x minus 1, which of course looks like this. And so it's this area in here we're interested in. Now, one strategy which would work would be to say, hey, wait, this is really two functions. This is y equals the square root of 2x plus 6. And y equals minus the square root of 2x plus 6. Okay, so how are we going to do that? Well, we have to integrate to get the upper area here. We could kind of find that, and then have to find a way to subtract. We could find this area and then subtract that. It's getting very complicated. You could do it. It'll work. But a different strategy is to say, hey, wait a minute. Why don't I just kind of turn it sideways? All right? Or another way of saying that is, let's integrate along the y-axis. That way, I have to find this point on the y-axis, and this point on the y-axis, and just integrate the difference between these curves along y. All right? So let's see if we can do that. Again, let's do a substitution here. I'm going to substitute this equation into here to try and find those points. So x minus 1 squared equals 2x plus 6, or x squared minus 2x plus 1 equals 2x plus 6, x squared minus 4x minus 5 equals 0. This again looks factorable. So that would be minus 5 and plus 1. Wrong? Yeah, that's. Someone said no, but isn't that it? So x equals minus 1 and positive 5. So the points are, those are the x coordinates. We want the y coordinates. So if x is minus 1, this is minus 2. That's this point, that's that point down there. And if x is 5, then it's y is 4. again, we're kind of turning our head sideways here. We want to integrate from -2 to 4. And now this is all dy, right? So we want to know what this x distance is, so we're going to have to solve for x here. So the first one is x equals y plus 1. And then the second one will be 2x equals y squared 6, or x equals y squared minus 6 over 2. And clearly this is, parabola is now the larger, the higher function. Well, it doesn't really matter. If we do it wrong, it'll just come out negative. But so we want to integrate y squared minus 6 over 2 minus y plus 1 dy. Okay, that looks simple enough. 1/2 y squared minus 3 minus y minus 1, or 1/2 y squared minus y minus 4, or minus 2 to 4. And again, we have a much simpler problem here now, right? This is just going to be y cubed over 6 minus y squared over 2 minus 4y. Minus 2 to 4. Okay, and what's that? So 64 over 6 minus 16 over 2 is 8. Minus 16 minus 2 minus 8 over 6 minus 2 plus 8. Okay, so plus, minus. The 8s are going to cancel. It's minus 14. And 64 plus 8 is 72 over 6. And that's 12. So it's minus 2, but really, that just means, yeah, it's just, there we go. Now it's 2. I don't feel like I was very clear about that. It's kind of messy sometimes, but the pearl of wisdom is sometimes it's easier to integrate along the y-axis, so that's what you should do. Save yourself trouble. So, okay, I'm going to stop talking. Of course, I have a worksheet for you. I'll start at this end. 22. And which function is the upper function? Is it the parabola or the line?
It's actually from the minus 1. It's from the negative 1 to 2.
So which of the functions is the upper function?
The quadratic. Well, I guess at 1, this is 6, or 4. At 1, this is 2. So this has to be f of x, right? Negative x squared plus 5 minus x plus 3. Okay. So
The second one says find the area in the first quadrant between 2x and x, 3x squared plus 1. So clearly, the lower integration point can't be less than 0, has to be greater than or equal to 0, right? I don't know, is it 0? Oh yeah, they intersect at 0, so it's 0. So what's the other point of intersection?
Just 1 again?
Yeah, minus 1.
This is too easy, right? Okay, and which function is the upper function? 2x minus x squared plus 1. Okay. This is obvious how you integrate it, find the antiderivative. Is everyone okay with this? I mean, this is just, to me, this is like really obvious substitution we can do here. Okay. Number 3 tells you right away, integrate dy, right? So, where do these intersect? 0 again, right? I just guessed. Plug in 0, they're both. Oh no, wait, that's x0. If x is 0, then y is 1. Okay. All right, anyone figure out where the other point is? Well, okay, square root of x over 2 plus 1 is square root of 1 minus x. We're going to square both sides, but that's probably going to introduce an extraneous root, probably. What it usually does. So x over 2, oh,
It's only
not
0.
in this case. What?
0. 0.
Minus x? Oh, that's 0. Well, we need another. Oh, okay, so wait. So it says, so if x is 0, y is 1. Oh, but it tells you the other bound is y equals 0, right? Okay. I mean, if x is 0, right, then y is 1, right? So that gives me the upper bound. And they give us the lower bound, bounded by y equals 0. So now all I have to know is which is the upper function.
It's better to draw this.
It is, yeah. Oh, but I turned off the, I'll just throw this in here. Let's see. So, aren't these calculators great? I mean, after a while you won't have to think. Plus 1. And square root of 1 minus x. So that looks like, oh, so it kind of looks like this, and then like that. And, oh, and y equals 0. So it's going to be like in here. No. Y equals 0. Where's, oh, between here and here. Oh, this is not so straightforward, is it? Oh.
so you could integrate along y, but you'd have to go up to here where they intersect, which I guess we decided was, yeah, which is right on the axis. So we have to go from 0 to 1, this function, which is this one. Okay. Square root of x over 2 plus 1 minus square root of 1 minus x. Okay. No, not x. That's the problem. I need y, right? So
Y squared.
if y equals square root of x over 2 plus 1,
Y squared.
y squared equals x over 2 plus 1, so y squared minus 1 over 2. Okay. So that's the first one. Y squared minus 1 over 2 minus, and then I got to find out the other one. So y equals square root of 1 minus x, square both sides, y squared equals 1 minus x, x equals 1 minus y squared, 1 minus y squared. Okay, so again, that's not a very, you can see why they want to, one reason you want to integrate this is you don't have to deal with integrating square root, some expression under the square root. Okay, now, questions on this, what we're doing? Did anyone get to number 4? Okay. 4 is introducing an idea that the book gives you, which is sometimes you can kind of skip the calculus, some of the calculus with a little geometry. So the problem looks like this. Y equals x squared, and y equals absolute value of x, which looks like this.
Other side.
Right?
You have to.
So we want all this area here, right? But both of these are
As equal. The same area.
even functions, right? When we want the absolute value of x minus x squared from wherever they intersect, which is minus 1 and 1. But,
2 double and 0 to 1.
sorry?
We can use if the function is even. And
Yeah, this is just going to be 2 times x minus x squared dx from 0 to 1. But I think, well, the place I got this from, I guess it was in the book, they wanted you to do something different. What they wanted you to do is to find this area here underneath the parabola, and then just use geometry. Actually, in this problem, it doesn't really make a lot of sense. I mean, I know this is 1 and this is 1, so it's a triangle, so its area is a half.
or we can use a
So this is just,
we can use the calculator to find the x squared under the area. Because you can find the point that's 2 functions equal.
you can find a point where the two, I kind of skipped that step. I just looked at this and said, where does this equal 0? And it's obviously 1, right?
So you know from 0 to 1, use the calculator can find the
Yeah.
integrate that quadratic function.
Yeah. Again, I don't, we're in calculus. I would just do this problem
Maybe for next week maybe for it's today, it's Thursday, yeah, maybe for Tuesday I'll bring in well, you know what, you're gonna run into it on the homework. Again, what they wanted you to do here is use the geometry here, the fact this is a triangle whose area is a half, right? So we really have 2 times a half minus this integral. Again, they just wanted to use the formula for a triangle to figure that out. It's not a very good problem. Okay, number 5, again, it's a calculator problem. Figure out where the points meet. I'm not going to do that. You might want to try that. I just kind of like this problem. What's the area between x to the n and x to the n plus 1? I like it because it's a little more abstract. You're going to find the area in terms of n. That should be pretty easy, I think, if you just follow the same steps, right? Okay, you know, I hope that when you do the homework, if you have questions, you'll bring them in on Tuesday. I know I haven't. On one hand, this is kind of from what we've done, this is a really straightforward section. It's kind of too easy, and yet I didn't do it very clearly. So I'm going to let you go, but if you have questions or have something you want to talk to me about, I'm going to be here for a few minutes.